The emperor penguin is the only vertebrate species that breeds during the harsh conditions of Antarctic winter. They have to withstand temperatures of -50 degrees and wind speeds of up to 200 kilometers an hour. How can they do this? The key to surviving for them is the formation of dense clusters, the so-called huddles. The penguins aggregate together to create more agreeable climatic conditions in their groups. These huddles show interesting dynamics. Every now and then they all perform a step forward. A wave passes through this huddle. How are these waves triggered? What is the dynamics that governs their movement? To address these questions, we have developed a model which has some similarities with traffic jams. Every penguin starts moving if the ideal point for him to be is too far away. This ideal point is a sort of compromise of having some distance to its neighbors while not being too far away from them. This means when one of the rear penguins is too near, one of the front penguins is too far away, it starts moving until it has reached a favorable condition again. If one of the penguins packed in a triangular cluster starts moving, he triggers movement all around him too. These themselves start to move, and the movement spreads out from the trigger and eventually covers the whole huddle. These waves can lead to the merging of several huddles, when two huddles approach each other during movement and eventually touch. They also serve to remove disorder from the huddle structure. Starting with a triangular lattice structure, where some disorder has been introduced, this movement rules starts to heal this disorder and the configuration returns to its ordered state. In the simulation, any penguin within the huddle can trigger a wave. There is no need for leader or pacemaker penguins. The triggering event is also not constrained to the front or rear end of the huddle, as the waves can spread in all directions. Even if two or more triggering events occur at the same time or in close succession, the wave fronts can merge, and in the end, the huddle has experienced only one wave event. Our model does reveal new insights on the complicated behavior of penguins trying to minimize the heat loss through huddling.